Welcome to P. Clark Calc, Practical Calculus for the Busy Math Student. And in this video, we're going to take a look at some things that can occur when you take derivatives of logarithmic functions. This derivative example is going to demonstrate both the simple and the general version of the log function derivative rules. And the simple version says the derivative of the natural log of x is equal to 1 over x. And that's derived from the exponential derivative rule and implicit differentiation. But ultimately, we come up with that fact. It's a pretty simple rule and an interesting rule because you have the derivative of a transcendental function and it's algebraic. It's a rational function. So we start with that. And then we have the general version, the derivative of the natural log of u. And so by chain rule, we would state that that's 1 over u, 1 over the logorand, the quantity inside of the log, times du dx, which is a derivative of the logorand. And typically, in most cases, we can just kind of jump to our final version of this rule that states that the derivative of the natural log of u is equal to du dx over u. So we can just simply write the logorand in the denominator, and then we take the derivative of that and we put it into the numerator. So we're going to start off using that one actually, because if we look at our function here, we have the natural log of a function of x, natural log of x cubed plus 1 plus x squared natural log x. So on our first term, if we write up our u substitution, we say u in a log function, the inside is the logorand, so that's x cubed plus 1. And du dx is equal to 3x squared. It turns out that with a little bit of practice, we almost never write the u sub for a log derivative because we can pretty much do the work as we're writing the derivative itself. So if we can recognize this first term in our function as the natural log of u, when we go to take the derivative, we write the logorand in the denominator, x cubed plus 1. And then we just simply take the derivative of that and place it in the numerator, 3x to the second. So that's the derivative of the natural log of x cubed plus 1. Just be careful with the algebra. There's nothing we can do there to simplify that. Don't try scratching out terms or anything like that and messing up good calculus with bad algebra. The second term has another major point besides the simple log rule, and that is that many times with transcendental factors we see this product rule occurring where I have two factors with totally different derivative rules involved. I have the simple power rule on x squared, and then I have the simple log rule on natural log of x. So we're going to go ahead and run that by our product rule, uv prime plus vu prime. So in this case, we're going to let u be the x squared factor and v is our natural log. So we're going to go ahead and put that into our derivative. So uv prime would be x squared times 1 over x plus vu prime, the natural log of x, times the quantity 2x. So if we just follow the rules, that's what it looks like on the first cut for our derivative. Then when we go ahead to clean things up, one thing that's worth pointing out here is because the log derivative is algebraic, is that when you see these types of product rules occurring, then we have to do the algebra here and simplify this. You know, x squared times 1 over x is simply x to the first. So we go to write the final version of our derivative, f prime. We have our 3x squared over x cubed plus 1 from the first term. And then here our second term now is going to be 1x. And then it's standard to write the algebraic factor first and the transcendental second. So we're just going to reverse the order on those factors and write that as 2x times the natural log of x. So there we have it. We've got our derivative rule. And to get there, we had to use both the simple and the general versions of the log derivative rule. Keep an eye out for the product here. That's not uncommon when we start getting into log and exponential derivatives. Here at P. Clark Calc, we do practical calculus for the busy math students. But if you'd like to learn more, you can find that on my textbooks, which are available for a nice price on Amazon. And until next time, I'm P. Clark.